Rory, please don't interrupt them. Even though you're allowed. No, you're allowed to. So I'm just.
it might be helpful.
He's got this machine with only PowerPoint that he wants to show off. So maybe he presses a button.
I will be as quiet as a 4'1" mouse.
What would be helpful is if there is questions and we miss it, that you interrupt us with those, because I think it would be good to actually. Yeah. Okay.
That we will do. So I'm opening the chat, let's see, what does our audience look like? Okay, people are starting to appear. So I'm gonna put up a slide. I nearly forgot now to use Zoom. Can you believe it? Because I've been in Teams and those types of things most times.
Oh no, Zoom's wonderful. And I can say that because it's a competitor.
Yeah, and if you did that 15 years ago, you would get fired, eh?
No, I love competition. I mean, I'm literally a Java developer at Microsoft. Yeah. I'm literally swimming. I'm a salmon up the stream.
Yeah, but I'm pretty sure Mr. Palmer would have thrown you out the window if you said anything promoting
it was the 90s. They were throwing dwarves any which way. You know, like I would have just charged them.
Yeah, but if I'm not mistaken, I don't know if it's an urban legend, but he once threw a chair out a boardroom window.
Yeah, he did. They tried to hire some people there and they didn't get it, so he threw a chair out of them. It's a well-known thing, though.
Okay, so our audience is coming on board. I just want to put this up. So we only have one person who actually said, I want to enter the draw. And that's Jabulu Mwandla, who is now automatically the winner of the JetBrains coupon. And I will be sending him a coupon. And it's worth $250, which, depending on where the rand is in the region of about 4,000 rand. So I'm always amazed when there's such a low turnout. Don't you want this thing? Do you get, does your boss buy it? That's lovely. If your boss buys you IntelliJ, then it's worth hanging on to that boss. And because it's a good sign. Paying for tools is hardly ever wasted. Oh, wait. I'm not trying to find the next screen. So I'm trying to see how many people we've got on board. Can you see, Rory?
Let me check on the YouTubes. I might be able to see, but you've got the Zoom access, so you can see the admin. I don't have the admin.
Oh, we've got participants.
We've got 6. 10 with 4 of us. Yeah. So okay. 10 all in all.
Yeah. We've been hovering a bit somewhere between 10 and about 18 at the most in some of the last few years. It's I think people are so exhausted, even on a Monday evening. Okay, so there's a question: how do we enter? So at the end of the call, or at the end of the meetup, I share the link in the chat. So not right at the end, so sort of 2/3 through, I'm going to share a link in the Zoom chat. And if you follow the link, then it's a feedback form to the speakers. And at the bottom of the form, there's a section where you can basically say, yes, I want to enter for the JetBrains license, and you give me your email address so that I can send you the coupon. You give me your name so that I can congratulate you. And if you have a Twitter handle, I can tweet about you on Twitter. And we do, well, basically, so tonight's entries will be announced at the beginning of the next meetup, like I'm doing now for Njabulu. So yes, that's how we enter the competition. And then something extra that's going to be in that form is for this meetup. Philip will tell you a bit more, but Red Hat will send each of us a T-shirt, but they will send it to Philip. So the logistics of getting it from Philip to you is going to be on your shoulders. So either you can pay to collect it, or you can go and collect it from him or something. He will organize that with you. And obviously, you'll have to tell us the size of the T-shirt you want, and give us contact info. And then Philip will organize the order and contact everybody to deal with getting the T-shirt in your hands. And so there's an extra gift. I'm still fighting for some corporate that will allow us to send pizzas to everybody, because it seems like that's the only thing that gets people on the meetup. But we haven't found them yet, and I'm pretty sure with the numbers we've got at the moment, that won't even be much more expensive, or even come close to what they've spent in the past on pizzas for us in the offices. Rory can tell you some stories about catering budgets that will
I can also tell you some stories about what you shouldn't do in a riot, which is hold an event.
So this was what, 2 years ago? We had what's his name? A good friend. Oh, he's not going to forgive me for forgetting his name. His surname's Kronia. Icebear on Twitter. So he's a huge contributor to ASCII Doc and Gradle, a whole lot of plugins, and the whole documentation in action. And he was giving a talk about that. He was here visiting his family, and there was this rioting in town, and we had one person show up. So that was 3 organizers and Icebear and 1 attendee, and he left with 3 boxes of pizza, an armful of T-shirts, and a JetBrains license. And that was only because he lived 2 blocks from the office in where we had Intellect that evening. So yes, that was an interesting one, and that was before we were recording everything. So yes, so I'm gonna unshare. Have I unshared?
No.
And why does it want to do a new share? So are you still seeing my screen that says congratulations?
I can share over yours, I think.
Okay.
Try that.
This is weird.
Okay. Now we can see Paul's.
Now we can see Paul's. Okay, so I think, Paul, if you can unshare, then we can quickly show all the faces and just say hi to the audience. And then somebody says they want buri rolls, but they do miss pizza. So please don't type your info into the chat that you about the T-shirt and size. You're going to have to wait for that link to the form that I'll share sort of in 15 minutes time or so, and then you can fill it in there, because then it goes into a one spreadsheet that I can send to Philip to deal with all of that. He doesn't have to scan through the chat. So who we have with us tonight is Philip Kruger and Paul Carter Brown. They're both contributors on the Quarkus project, and in no small way. So I would be proud to stand up in any room and say South Africa has some of the greatest talent when it comes to development. And once the world realizes it, the local organizations are going to be in trouble because they won't be able to afford us anymore. There are South Africans contributing to things that you never see. When they show the JPL control room, when something lands on Mars, there's a few South Africans in that room that had no significant part to play. And they're all over. Some of them even build electric cars, but we don't talk about them. So these two gentlemen, as I say, is building this that part of this Quarkus project, and I'm going to hand over to them to tell you more, because I haven't seen their presentation, and I'll just be putting my foot in my mouth if I try. So thank you everybody for coming. Look out for the link. Post your questions. We'll pass them on. And if you enjoy it, fill in the comments. If you want a piece of that chance to win the JetBrains license, fill in the feedback form and tell your friends to join us as well. So over to you, gentlemen. You can share your screen and go for it.
Great evening, everyone. Philip, did you want to start with the intros?
Yeah. So you can go to the next slide. So we're gonna start with the intros. This is just what's coming, basically, agenda. Then Paul is going to go through some slides just to give us a kind of overview of Quarkus for those who've never heard of Quarkus before. Then I'll do a demonstration, and then Paul is going to actually show some very interesting real-world usage, because he's actually been using this in production. And then it does say Q&A at the end, but obviously if you have questions, please interrupt us as well, and we'll answer them as we go. Okay, next slide. Okay, Paul, you can start by introducing yourself if you want.
Cool. Evening, everyone. So I've been in the tech industry since 1996, started my life on IBM mainframes, worked quite a bit with Adabas Natural, and then into C, C++, Visual Basic, you name it. And in about 2001, I would say, I jumped over from the Microsoft ship to the Java ship when sort of .NET started coming out, or even before then, and worked a lot with Java EE across pretty much all of the app servers out there. I've been the CIO of a telecoms company for 10 years. And then in about 4 or 5 years ago, started my own company with some colleagues in the payments and telecom space, building real-time telecom services as well as solutions in the payment space. We're very much a Java shop, although we do a bit of .NET and PHP and other things here and there. But I pretty much say I've been hands-on in Java for about 20 odd years. And in the last year or 18 months or so, very involved in the Quarkus community.
Okay, cool. And I'm Philip. I work at Red Hat, specifically working with MicroProfile, SmallRye, and Quarkus. And in Quarkus, I maintain the biggest part of my work is maintaining the GraphQL extension or extensions, and then also OpenAPI and Swagger UI. And then I've done some other small things in Quarkus, like the Def UI, or parts of the Def UI, and I've got another extension in Quarkus that I'll show you a bit later as well. But yeah, I've also been doing Java for 20 plus years, Java, Java EE, MicroProfile, and so on. Cool.
Cool, so let's jump into it. I'll assume that that people haven't used Quarkus, I think we can start with the basics. And really, you know, Quarkus, and I'm not a Red Hat guy. I never worked for Red Hat. I just, you know, from the outsider looking in, and having been in the Java community, and when Quarkus piqued my interest, a lot of what Quarkus is all about makes a lot of sense to anyone who's been in Java for a while. And it's really that there's been this progressive movement of software deployments moving from a very large monolith, single process with tens of gigs of RAM running, typically developed through some sort of waterfall approach, where maybe you're doing a release every 3 months or every 6 months, and you've got an ops team that's trying to keep this monolith running, probably connecting to some Oracle database with thousands of concurrent connections. And that's kind of the world that Java was born out of. And it still impacts a lot of Java thinking today, but software has moved on. And it's moved on in that the deployment artifacts are often a lot smaller. They have a far more specific role in terms of the functional domain that they play in. And their lifespan or their life cycle is a lot quicker than what you would typically have in a monolith. So, I mean, a monolith you could start up and, you know, people would have these uptimes of servers for many years, and the apps would be up for months, and, you know, that was what you aim for. But now with, you know, so much innovation in the software world, people are needing to deploy things daily. I think there's some ridiculous quote of Amazon do some form of production deploy, I think 10 per second or something like that in AWS, just their own software. So, you know, there's a lot of movement to deploying things in the cloud, having a short deployment time, having services boot up very fast, all the way through to nowadays where you are, you know, even moving into a serverless space, which is you're not consuming any compute resources. A request comes in, you service that request with a process, and the process shuts down. It can be, you know, sort of sitting lukewarm, but often you end up boosting up a process, handle a single request, and then killing the process. And that's where the world is moving. And Java has not necessarily been in that space. You know, there's been a lot of innovation around languages like Go and Node, etc., in optimizing things for short runtime. And now, you know, Quarkus's focus is saying, well, let's take Java, what it was, what we know, still have the entire Java ecosystem, everything goes behind it, but now allow Java to now compete and feel at home in these sort of microservices and serverless type environments. In terms of the deployments, they are happening on Kubernetes with Istio, Knative, ECS, which we use. Everything is about deploying things in some sort of a container orchestration environment. You know, the days of using raw-tin and installing VMware and, you know, installing an application server and running apps, those days are disappearing pretty fast. So I've sort of, you know, a few of these slides I've mentioned is that, you know, the historical stack, you've got your operating system and your, or, you know, either raw operating system or some sort of a virtualization, a JVM, which could be several gigs of RAM if you've got a large heap, if it's a very large monolith. And that apps, and then you could have an application server that then runs on that, and you then deploying wars or ears into your application server. So that's the sort of typical model of a JBoss or a Wildfly, or, you know, back in the day, WebLogic and you name them. The app servers were meant to be these big runtimes that stay up for ages, and you're deploying these applications into them. The modern stack is pretty different, because now you're generally trying to create a runtime, which the word escapes me right now, but effectively it is like a Docker image or something which does not change. You boot it up, you shut it down. There's no persistence. There's no storage between boots. And it's that movement. I know there was this analogy a while ago of was saying we're moving from servers being pets to being cattle. You know, we used to, I don't know if you guys know, in the days, you used to set up servers and you would know them by name and you would know the host names, and you would typically call them something geeky, like some name out of Lord of the Rings or something for your servers or something like that. Nowadays, servers are completely nameless. They're just cattle. You've got virtual machines or containers that are just cattle. You are booting them up, and if they misbehave, you shoot them in the head and boot up another one. They're not pets anymore. You don't have any attachment to them. You boot them up and shut them down pretty quickly. And that's where things are moving. And your whole paradigm of scaling and resilience and reliability, all of that comes from the ability of being able to boot something up fast, fail fast. If it dies, kill it quickly and replace it with another one. And that's what we're seeing in the serverless world, and certainly in the microservice world.
And also maybe worth mentioning that there's a one-to-one relationship typically now with your app and your app server.
Yeah, no longer deploying wars and having these very complex class paths. Class path issues between drivers and you name it, all of that stuff just add a lot of complexity. So then just in terms of serverless development, so, you know, the languages, you know, Node.js, as we know, has really come up in terms of development friendliness and what users, you know, have been, what devs have been using in production environments. This was just a community sample. Guys put out a survey on serverless.com in terms of what people were using as a language in a serverless environment. And a lot of the reason behind Python, Node.js, and Go and its popularity is all around the speed of boot up time. You know, you cannot, in a serverless environment, have something that takes 30 seconds to boot. Your user will have gone away. You need something that takes preferably milliseconds to boot up, service a request, and die. And in that, use as few resources or as little RAM as possible. And you know, Java has been lagging in that field, and this is where Quarkus has put in a lot of effort to try and say, well, let's turn that on the head. It doesn't have to be that way. Java is not, you know, your Java from 10 years ago. Things can move on. There's been a lot of innovation in the Java space in the last 5 years or so, and I think Quarkus has been in the forefront of a lot of that. So, you know, a bit about Java and containers, as I say, is with the size of hotspots and the heap, your container density with Java has always been a lot lower than the equivalent of a Node.js or a Go. The memory footprint of Java has been very high. The background noise, the usage in terms of the JVM itself is pretty big. So the density that you get out of Java has traditionally been a lot lower, and Quarkus is really set out to change that and say, well, does it have to be that way? Can't we turn things on its head and get Java to compete in terms of, you know, Node.js and Go? And later on in the demos, we'll show you just how well Quarkus has done at competing in that space.
And maybe also worth mentioning here that the reason why this is important is because of cloud and how cloud billing works. And if you use up all your real estate just to get to a vanilla state, you pay for doing nothing. And that's why you have to kind of try and use as little as much as possible real estate in your cloud.
Yeah, and you know, certainly in our business, we've seen that a lot. You know, especially when it comes to dev environments, etc., you don't want to be booting up things that are taking gigs of RAM, because your AWS bill or Azure bill or Google Cloud will go through the roof. So yeah, so Quarkus was kind of, you know, I don't know, you know, Philip, if you could probably give some of the history, but I think it was probably about 2 years ago or so that the Red Hat team looked at where Java was going and came up with this whole new idea of saying, let's try and build a cloud native Java framework which moves as much of the what is typically done at runtime in terms of annotation processing and that sort of thing, move that into build time and be able to target cloud native microservices and serverless with Java being the language, but without the traditional overheads of large heaps and long boot times.
Yeah, I actually don't know the history off by heart myself. I know it was actually various teams in Red Hat that were all innovating, kind of trying the same thing. And at some point they decided to kind of just work together, and that's how Quarkus was born.
Okay, so in terms of what Quarkus gives you, so in a typical startup time scenario, you are looking at milliseconds as opposed to seconds. We can show you some of that in the demos in terms of how long it takes to boot up a Quarkus app, both in terms of if you build it as a native executable using GraalVM, or just running it as you know, on hotspot. So you know, some people get confused and think, oh, Quarkus is only for building native applications. That is a decision you can make at build. So you can decide at build that you want to build a native app using GraalVM, but that's absolutely not a necessity. In fact, you know, in our production environments, we don't use GraalVM, we use hotspot. The performance is better than GraalVM. Obviously, the footprint is a bit bigger, but the benefits of Quarkus are not just in terms of native, it's also in terms of running on top of your hotspot JVM. It gives you optimized frameworks, and that a lot of the extensions are integrated in such a way that a lot of the heavy processing is done at build time. And then you end up with this app that is either on hotspot or GraalVM, being a lot lighter weight, faster to boot, and really suitable to a microservice environment or a serverless type environment. Yeah, and just that thing saying that the hotspot is optional. In our world, we prefer to use hotspot, but GraalVM is there. You know, there's some things, if you're using some of the old libraries that do a lot of reflection, etc., it can take a long time to build in GraalVM, but it's not a necessity. Plain hotspot works a treat with Quarkus. So in terms of some figures of what you get, so if you're just deploying a simple REST application, so you've got some REST endpoints, and you build that on top of hotspot, you're probably looking at a memory footprint of around 70 odd megabytes. Obviously that's optimized, you've got a small heap running, but it's a step, you know, if you then go and get that same app and you deployed it with GraalVM, you could get it down to about 13 megabytes. And that's resident set size. That's not heap usage. It's the full process usage of your OS, of your RAM when that process is running. And you compare that to a traditional cloud stack, you're looking at 140 megabytes as a minimum. I've got some demos showing some of the stacks out there that can go into hundreds of megabytes RSS just for a simple REST hello world type application. When you start adding database access and Hibernate and JPA and these things, then still GraalVM, it goes up, but it's still a hell of a lot lower than the traditional stack, and Quarkus on top of hotspot is also still significantly less than what you would find on, you know, Wildfire or JBoss or Helidon or any of the other sort of typical application servers. And what that really ends up bringing to you is this ability to utilize Java, but taking it into the world of a far higher deployment concentration, being able to have a Kubernetes cluster and deploy hundreds of nodes or hundreds of tasks on it, not having to worry about, oh, we're running Java, it's going to use 2 gigs of RAM just to run this thing. You know, those days no longer need to be with us if you're running Quarkus. It's extremely light on memory, and from a performance perspective, when we get into the demos, I'll show you the some of the performance figures that you can get out of Quarkus as well. In terms of boot time, I think I've mentioned this. I mean, GraalVM is pretty phenomenal as a native executable. You're getting sort of 10 millisecond startup time. On hotspots, even, you know, it's still extremely quick. I'll show you sort of 600 odd milliseconds of it on my laptop. But a traditional stack, you could be looking at 4 or 5 seconds. We used to run an application server running our architecture, and it used to take about 40 seconds to boot up. And in the demo, I'll show you what it does in Quarkus. I think another key idea behind Quarkus was to make for developer joy. So making you enjoy writing Java again. You're not having to make a change, compile something, deploy it into an application server, wait for the results a few minutes later. It's all about that instant feedback, you know, all our PHP, etc., where you can make a change in a file and see the results immediately. And that developer joy is really what Quarkus is trying to focus on as well. Another sort of goal of Quarkus is to cover both worlds, whether you're looking at imperative type coding scenarios or reactive. Quarkus works in either. It's got extensions that are built around the reactive paradigm, reactive Hibernate, etc. But also the plain old imperative style is there, works perfectly, and you know, unless you're in super scalable type environments that you need the ultimate throughput, you know, imperative works. It's much easier. I think from a coding perspective, it's a lot easier to follow. But Quarkus is effectively saying you can code either way, and you can mix and match inside projects as much as you want. In terms of frameworks and standards, so you know, Quarkus set out to be standards compliant, especially around Eclipse or Jakarta microprofile, to try and not, you know, build Red Hat's view of what an API should look like. Rather say, let's build Quarkus on top of open standards. And then where the standards don't necessarily cover certain use cases or that sort of thing, go beyond the standard, add additional options or functionality. But there's no, you know, if you're going from like a Java EE world or something like that, or even from a Spring Boot world, Quarkus will seem very natural. The annotations are there. They've got extensions for Spring Boot so that you can use Spring Boot annotations if you want to. And then there's a large number of plugins and extensions covering everything from generating Kubernetes deployments to Apache Camel. It's built on top of Netty with Vertex. There's Kafka plugins, you name it. If there's a project out there that you think is useful in Java, it's probably an extension in Quarkus that you can just plug in, go to the single configuration file and get up and running with the extension pretty quickly. Right, so now I'm going to jump over to Philip, who's going to give us a quick demo on some of the Quarkus functionality.
Okay, so before I share my screen, okay, let me share my screen. This one. So this demo, what I wanted to first show is how I started this demo. So I basically went to code.quarkus.io, and this is also a good place to see all the extensions that's available, at least in Quarkus. I'll show you another way that you can also get extensions, but you can see there's really quite a lot of extensions. I'm not going to go through all of them, but so I basically started with, I want to build a REST endpoint. I'm going to use Jackson to do my JSON marshalling, and then I added OpenAPI, which is this one here. So I basically started with this, then I downloaded it, or you can push it directly to GitHub. On that note, this is actually all available in GitHub. So if you go to GitHub, Josie Jug, yeah, I don't want to switch it tab. Yeah, now I switch tab. Let me do this. So you'll see the code that I'm demoing, and you can go play with it yourself. Right, but this is just a very easy way to get started. Even after you've started your project, you can come back and let's say you want to add, I don't know, Hibernate, then you can just grab, if you're using Maven, you can just grab the command off here and then run it in your console, or you can just copy the little POM extension that you need. You can also open the extension guide. So you'll see that we have guides for quite a lot of things. So this is example this one, but if you go to the main guide, you can find guides for most of the extensions or specific use cases, like getting started with React or something like that. So I wanted to mention those two. The other set of extensions that you can look at is Quarkus, which is outside of Quarkus core. So it's maintained by the community, but it also works with a specific version of Quarkus. So there's quite a few in here as well. This will be more niche extensions, so extensions that not necessarily used every day, but it is used by people. So as an example, one of the ones that I maintain is this one. It's a logging extension that allows you to change your log level using a REST endpoint, and then it also gives you a UI if you want, where you can see the log, it will stream to your browser, and you can change your log level with a UI, which is quite useful sometimes. Okay, so I've now created that resource, or I downloaded that application, and what I got is a REST endpoint. So I'm using JAX-RS, but this could also be a Spring Web controller if that's what you prefer. So in this case, I'm just doing a plain old hello world, and then I also have a test that will test that is hello world. You'll also see that I use Quarkus test, so this makes testing very easy. You don't have to worry too much about how to connect or start the server or you connect to it or whatever. You just do this, and this will start your server, do this test, and check that it's hello world. So what I want to show is, I'm going to start off with showing you dev mode, which is part of that developer joy that Paul spoke about, so that you can see how the hot reload works. And then I want to show you continuous testing, which is new in version 2, which is released and will be available, I think, from Wednesday. The platform will be available. And then I'll quickly show a native executable and dev services. Right, so I'm going to start here. I'm going to start this application. Can you see this? Let me make this bigger as well. So I'm basically just doing Maven and Quarkus dev, which will start this in dev mode. And basically you can you start your day in the morning by doing Quarkus dev, and then that's the last time you start your server. And then from then onwards, any change that you make will be picked up, and you'll see the change. So you'll see now my server is up and running. It will show me what extensions I'm using. And obviously now if I go to localhost 8080, I'll get this initial page that's been generated for me by the code.quarkus. Now this page here is just a static resource. You can see it here, so it's just in my meta-inf resources. There's a HTML. You can delete it, or you can change it to be your own static resource. There's some information on here. There's also a dev UI, which when you start in dev mode, this is available. This is not available in anything else than a dev mode, because it's specifically for while you're developing. And this just gives you a UI on certain things. As an example, you can change any of the configurations. So we have a configuration file called application of properties where all the configuration live. But you can also just change it here. So let's say, for example, I want to make this version 1, then this will change it. And all that it really did is it went and put this in here and did a hard reload. So the version is actually already, if I reload this page, you'll see that the version up here has changed. Right, and then if I edit the file directly, the same will happen. So if I save this and I refresh here, it will go back to the default, which is my artifact ID. And then for every extension, basically, that you added to your application, there'll be a block here, and some will be giving you some actions that you can perform, and some will just tell you, okay, you have this extension and here's the guide. So as an example, Arc is our CDI dependency injection framework, and you can see, you can list all the beans, and you can, if you have events, you can actually fire it from here manually, and you can see which beans we've removed when we optimized and so on. What we are interested in for this demo is the Swagger and Swagger UI or Open API. So this is built in if you add Swagger Open API, and then you have this UI in dev mode, which you can also make available in production if you want. And here's our endpoint, so we can try it out, and you can see hello world. And then I can now go and change this to say hello Josie Jug, and then just hit it again. And now it says hello Josie Jug. So I don't have to compile my code and redeploy an application and any of those. And this hot reload works for code changes, test changes, property changes, static resources. If you add something to your POM, so you add an extension, the reload will still work. Right now, one of the things that happens when you actually do a build is you also run your tests. But if you run dev mode, you never build again, so you never run your tests. So what we have now in version 2 is something called continuous testing. And you'll see at the end of my log file here, make this a bit bigger. In fact, let me actually change this back to world first. Otherwise my test will fail. Right, so you'll see at the bottom of my log file, I have this, and this is sticky. It will always be at the bottom. Now, when you start in dev mode, this will be paused, so it's not running any tests. But if I press R, it starts running my tests. So it will now run. I only have the one, which is the one that tests this rest easy. And from now onwards, as I code, the tests will run. So if I now change this again to Josie Jug, if I save, the test will run, and I can immediately see that my test is failing. And this is clever enough to know what tests to run as well. So if I have 50 tests, but the code that I change only affect 2 of the tests, it will rerun those 2 tests and check that they still pass. So this makes your test first development very easy and instant. And it actually gets to a point where you might not need dev mode anymore. If you have 100% test coverage, you can start Quarkus rather than doing Quarkus dev like I've done now. You can do Quarkus test, which means it doesn't start up a test mode. It just starts this thing that checks your test the whole time. And as you code, you just make sure your tests stay green, which is also quite cool. Then you have a few other options in dev mode. So I'm not going to go through all of them, but you can obviously rerun the test manually if you don't, if you don't believe like this one is failed. Let's fix it just quickly. In fact, let's fix the test. Hello, Josie Jug. So this should now my test pass again, but I can manually rerun it by pressing R. I can toggle a flag that says only run the broken test. So this is useful when you have quite a lot of tests and you're busy fixing one scenario and you don't want to rerun all the tests that's affected by the code that you change. You only want to test the broken one, then you can switch that on. Right, and then if you go back to, let's just go back to dev UI, you'll also see at the bottom here, you also have a UI for your test. So you have a UI for your log file. So this will be your normal log file. You can clear it and you can also change the log levels and so on, yeah. But you can also see that the test is here. So it will start up with test not running, but I can start the tests, I can rerun the tests, I can toggle broken only, and so on. And I can also go to the test results screen, which is this one here, where you again have all the test guides but also all your tests will pop up here. So I only have the one, but if you have 50 tests, you'll have 50 lines here with all the tests and the outputs. And this will update as well. So as an example, let's break the test again. So let's do that. And if we go back here, this it's got a WebSocket connection that tells this browser that it's broken. Right. So that's continuous testing and dev mode. What I want to show you next is there's a native executable. So we'll start off by actually just building a jars. So Java Maven install. So this is the hotspot or the JVM mode, like Paul explained. So this is not using Graal yet. And sorry. So this is typically if you want to use hotspot for production or any of your environments, you'll build this artifact and then you'll start it. Okay, it's running the tests as well again. So now I can do Java minus jar and target Quarkus app and Quarkus run.jar. And then you'll see it started up in, it's actually quite slow, 1.4. But this is now a full-blown application that started up in that. And again, this is now usable. So if I go to, obviously dev mode won't work, but I should be able to go to Swagger UI, yeah, and test it out, right? And then I'm going to show you the more impressive one, which is a native mode. So this, the build takes quite long because you have to move the performance penalty somewhere. So what we gain on startup, we kind of move to build time now. So this build takes quite a while. What I'm doing in the background, it's actually building against a Docker image as well, because I haven't set up Graal on my own machine. So if you didn't set up Graal, you could let it run against either Podman or Docker to compile the native image. So while that's going, if there are any questions, I can take that so long. Otherwise, I can tell you what I'll show you.
I see there's a question, Philip, here from Maranza. So the question is, are there people currently using Quarkus in production? So I can answer yes, because I know we are. And I'm sure many other companies are. So yes, it is. I mean, version 2 is being released this week. It is most definitely production ready.
Yeah, and if you go to the Quarkus blog, you'll find we do have some user stories there as well. I think you can just look at the tag and you'll see all the user stories. We have big clients using it that has shared their successes online.
And then, is Quarkus a project under the Java EE, Jakarta EE ecosystem? Can you please make a comparison with what the Spring team has? I'm just trying to make sense.
If I understand the question correctly, so Quarkus will never be a certified implementation of Jakarta EE. However, we contribute and support some of the APIs underneath Jakarta EE, like JAX-RS and CDI and so on. A lot of the contributors to those APIs work for Red Hat. And the same goes for MicroProfile. MicroProfile, we are actually, I think, version 4. Version 2 of Quarkus will be a version 4 implementation of MicroProfile. I myself contribute to the GraphQL MicroProfile and to the Open API, and most of my colleagues contribute somewhere on those. With regards to Spring, I saw there was a Spring native question as well, and trying to compare those two. So I think, Paul, you've also said it. Quarkus is not only for native. We've optimized, our work actually goes into optimizing the JVM. So we're basically doing, if you go and look at the code and you look at all the extensions, for every library that we use, we do as much as we can during build time. So if I just take my own example of stuff that I'm working on, for Open API, typically how it would work is if an application starts up, on startup, we scan all the annotations, and then we build the OpenAPI document, schema document that we make available. Now that we do all, or most of it, we do on build time, which means your startup time is suddenly much quicker because there's no annotation scanning and there's no building of schema documents and things like that. And every extension does that. It says, what can we move to build time to optimize startup time? So it's not comparable to Spring Native in that sense that Spring Native is based, as far as I understand, I'm not an expert on Spring, but it's basically getting Spring Boot to work in native mode, because getting an application to work in native mode in itself is quite a lot of work. So,
Philip, I can quickly add there.
Yep.
So Spring Native essentially has two elements as well. The one is Spring AOT, which is basically the same type of work. In other words, the runtime annotation processing is replaced with compile time annotation processing to optimize everything for a quick runtime. And then you have an application that will start faster. On the
a Java application. Okay, cool.
Yes, and then you can apply Graal VM to make it a Graal application.
Okay.
So
similar, very
actually,
similar.
yes. So philosophically, they are very similar. I think the guys probably borrowed a lot of ideas. I had this conversation with the Spring team in January 2018. So where I suggested that they consider that route, and there was pushback at the time, so it seemed to have paid off. Because I believe that was the way to do it, and I think that's the same way. And so you get benefit by using it, and over time the support for IoT will grow in terms of the various projects, and there will be guidelines on what do you do to make your project friendly. And there Quarkus is ahead of the game, because you have a model for how that is done in Quarkus. And I mean, that's a lot of the work that you do and other contributors, is to make the libraries friendly to that.
But I think the good news is that this is possible. You know, we can definitely say that this is the new way of doing things, and maybe Quarkus is setting the pace, but it's good if other frameworks are following the same, because this means that this this is not just a niche thing that Red Hat is doing. This is how things are working now. So it's actually good news. All right, so my my native is finished building. So now you can still see my screen, right? So now if I now run this is now a native Linux executable, and you'll see that it now starts in 0.024, which is unbelievably fast, and fast enough, like Paul said, that I can actually scale to 0. And as the request comes in, scale up, serve the request, and shut down again. So that's native mode. Now, the last thing that I want to show before I hand this back to Paul is dev services. And for that, I am going to need to do, let's just do that.
Just while
so
you're
now,
typing there, okay, sorry, carry on, Philip.
No, go for it.
No, just part of the question was also just saying, is Quarkus a standalone framework? Does it have to be embedded with something else? What is the difference between Quarkus and Jakarta EE? I can take that question. So if you look at Java EE, Jakarta EE, and the history, it went through a period of stagnation. I think it's fairly obvious to anyone that things slowed down in terms of the number of specs that were coming out. And Eclipse Microprofile was then an effort by a large number of the larger software providers to try and create a set of specifications more aligned with the way Java was going around microservices, etc. And Microprofile took a lot of the Jakarta or Java EE specs, such as JAX RS and JTA and JPA, and numerous others to create a micro-profile set of standards which doesn't cover the whole of Jakarta EE. It's a subset of them along with some new standards, so around OpenAPI and GraphQL and various others, to create a more modern, in inverted commas, set of standards. Quarkus is an implementation of those standards, just like JBoss is an implementation of Jakarta EE, or WebSphere is an implementation of Jakarta EE. Quarkus is an implementation of the micro-profile specs with additional things as well, but with a focus on saying let's also make it natively GraalVM compliant so that you can very easily utilize GraalVM as well as utilize Hotspot, but boots up much faster and use a lower memory footprint. So it is standards-based. It is standalone in that effectively you have a Maven project or the Gradle project. You give the Quarkus build plugin your jars or your source, as long as the set of extensions you want, the configuration file, and it packages all together, either creates a Uber jar or a sort of exploded jar that you can then just run with Java minus jar if you want to. There's no application server you're installing or anything like that. It is effectively the same as Spring Boot, that you've got this Java jar you run and off you go.
And in terms of the implementation, oof, I hear myself. Can you maybe mute Paul? I don't know if it's you. Yeah, that's better. In terms of the implementation, a lot of the implementation work actually sits outside of Quarkus. So for micro-profile, most of the implementation sits in a project called SmallRye. And if you look at, for example, SmallRye OpenAPI, which is an implementation of micro-profile OpenAPI, that's being used in Quarkus. It's been used in Wildfly, EAP, OpenLiberty, Helidon, and more, Cumuluzzi, or I'm not sure if I pronounce it correctly, and the same for GraphQL. Those two I know because I work on those two. So they actually used in other application servers, but also in Quarkus and Wildfly, because it's just an open source implementation of that specification. And the same for Jakarta EE. So REST Easy implements JAX-RS and REST client, and it's used in Quarkus, but also in Wildfly.
Yeah, and Hibernate with JPA, etc. There's a lot of cross-pollination.
Yep. Okay, so I still hear myself. There we go. Thanks. So what I've done now is I've basically said, let's build something that has a database so that I can show off the dev services. So what I've added is I'm using a library called Panache, which is Quarkus specific. And that's just a library built on top of JPA or Hibernate. And it allows me to do something like this. So in my example, I have a rock band. A rock band has members, and a member plays a role in the band. So I have these three plain old Java objects, but with the difference that they extend Panache entity. But you can see a rock band basically has a name. It started at some point and it has some band members. And you can see I'm using JPA to assist this. And then I have a few helper methods like find by name and add member. And then a member is very basic. Again, just extends Panache entity, and it has a name and a role. And a role is just an enum. But I have no service that fronts it because I've extended Panache entity. So the service is being generated for me. And if I go to my JAX-RS endpoint, I now say that under path, I now have all of these methods on Rock Band. So I have all the basic CRUD operations available that's been generated by Panache for me. So I can list all, that will return all the rock bands in the database. I can find by name, that's my own methods. I can find by ID, which is maybe more useful. I can do removes or deletes and edits and all of the normal things. So Panache just gives you a very easy CRUD framework on top of JPA. So I basically have all of these services, REST endpoints. I've got no database started. I've got no Docker instance running. The only thing that I also have is in my POM, I've added these two dependencies. So I've basically said I'm going to use Postgres as a database, and I'm going to use Panache ORM. Right, that's just that library that I'm showing off. Now, if I start this again in dev mode, so Maven Quarkus dev. Oh, the other thing that I have that I've got about is I've got this import SQL, which just populates a few bands into the database, just so that I have something to play with. And then in my application, I've got nothing in here except when it starts in dev mode, which is what this says, because you can have your config to only apply on dev or test or prod. I'm going to create the database on startup. I'm not going to do a drop and create, because on hot reload, I want to retain the data that I'm busy playing with. And then I also tell it to import the SQL script, which is the one that gives me the initial rock back, right? So now when I go back to here, you'll see I now have my Rockers API, and I can go and query all the Rockers that we have, right? And it will come back with some JSON file with all my Rockers. And I can create a new band or add a new band. So let's say we want to create Queen, and they started in 1970, let's say. Not sure exactly when they started. Right now I've added Queen, and then I can add members to the band. So let's say Queen and Freddie Mercury, and he's the lead vocals. Right. So what I've shown you now is the a REST endpoint that actually persists in a database. Now, where's the database? And that's exactly what dev services is. So we figured out based on this dependency that you need a database, a Postgres database, and you haven't configured anything with regards to that database, a URL or a username or whatever. So when this starts, we actually start up a container for you. And we say, oh, you want Postgres, you didn't specify a version, so we'll give you the latest one we support, and the test container has been started in the background. And this dev services is not just for databases. So we're busy adding Keycloak and Kafka and any other external service that you typically use when you develop. You don't need to configure or set up now. And so what you'll typically have is you'll have nothing for configuration for it, but then you'll do prod, or actually something like this, /prod, and then blah, 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 all the configuration that you need for your production or test database. So that's quite handy in terms of making the developer's life easier again, because it's typically always to set up your dev environment with all the external services that you need. And then what I've done just for fun is I've also added, just to show a real full example from front end to back end, I've added an index HTML with some JavaScript that will call that backend, and I just added it or included into my meta-inf resources, and it will become available now if I go localhost 8080 site. And now I have a front end with all my bands, and I can go and say that we're going to create a new band called the Quarkus, and we'll start it for today, and then we'll add Paul will be the lead singer, lead vocals, and I will play, let's say, the drums. Right, so this is just to show now we have a JavaScript front end calling our REST endpoint, saving it in the database, and I didn't have to configure anything with regards to database. Yeah, that's my demo. I'm going to stop sharing, and then I'll hand back to Paul. And if there's any questions, we can maybe field them now. Any questions with relate to this? Paul, you're still muted. I'm not sure if you're trying to talk.
There you go. No, I wasn't. I think what I'm going to do, so if there's no questions.
There is a question around the extensions for IDEs. And I happen to work for a company that works well with Visual Studio Code. And we do have a great extension for Visual Studio Code for Quarkus. So go give it a try.
Yeah, so I think the only IDE is the one that I'm using doesn't have support. Me and Paul actually doesn't have support, a plugin for Quarkus.
Yeah,
but I'll also say that I don't.
Yeah.
It's not something I miss necessarily, but what it does give you some stuff like the stuff that I showed you in code.quarkus.io. Code.quarkus.io also have a REST endpoint, which these IDE extensions hit to allow you to generate your application directly into your IDE. I don't really miss that necessarily, because I usually start my applications manually anyway. And then it has some code inside, for instance, in your application properties. It knows the set of properties that's available, and that is quite useful. But yeah, IntelliJ, Eclipse, and Visual Studio, and the online ones. What's that online one? I forgot the name now.
Codespaces.
Yeah, Codespaces and Eclipse J, right? Yeah.
Okay, so a few more slides we can go through. Just so I think one of the things is, and just going on from the questions earlier, is to, what's this magic that's happening? So when you build, and we'll just take Maven as an example, you have a Maven plugin, which is the Quarkus Maven plugin. It looks at the combination of the source code in your project and the dependencies that you have, and those dependencies could be, plain old Java jars, it could be, SLF or J, it could be your own custom libraries, doesn't really matter what it is. Then your Quarkus extensions, which again are just jars, slightly, specially coded to do a lot of funky stuff at build time. And then the Maven plugin looks at all the jars in the project. It looks at the application properties, so the configuration of your project. And then it starts doing all of what is effectively, building the project, processing all of the annotations in the project, the extensions in the project, and actually trying to build a set of bytecode which would be statically initiated as soon as the JVM starts up. So it's trying to really optimize a code path to boot up your application server as fast as possible, and plug into that any of the configuration information that can be deduced at build time. So as I mentioned, annotation processing, dead code elimination, tree shaking, you name it. It tries to look at build time and get rid of anything that's not used, and create this optimized set of bytecode to boot up the app server as fast as possible. Bind into the sockets and start listening as soon as possible, so that your time to first response is, as you can see, within milliseconds. So the benefits are you're doing stuff only once, not every time you boot it up. Because you're not doing analysis of the whole class path and annotation scanning, obviously that saves a lot of time as well as a lot of memory, because you don't have this class loader running through loading all of these classes and then having to destroy the class loader, replace it with another one in order to free up the memory. There's a lot of sort of hokey-pokey going on in a typical application server to boot up and then at runtime try and get an ear or a wall running while not consuming gigs of RAM. And then that takes time in itself. So diving a bit deeper, and kind of why Philip had invited me to talk tonight is that our company, which is called Ukesh, we're in the payments and telecom space, as I mentioned earlier. We have been building software products in the banking space and the payment space for a number of years. And going back to that, as well as in my previous role in a telecoms company, we have built a lot of stuff on Java EE technologies and Spring Boot technologies. So I started my early days in Sun Application Server, moving through to JBoss, all the versions of Glassfish, Bayara, Tommy, Helidon, Thorntail. I played with all of them, and probably, so I think it was at the beginning of 2000, I came across Quarkus, and we sort of took the decision in our company to standardize on Quarkus as our framework in Java. Just in terms of a few of the things you probably haven't heard of Akesh, because we are a B2B company. We did actually have a B2C proposition around people scanning QR codes to pay car guards and things. We actually ended up transitioning that business to Telkom. It's now branded as Telkom Pay. We do a lot of work with Nedbank. Buzzbox is a product of ours. It's a corporate PABX product, also built on Quarkus. We're doing some exciting work with TikTok and their rollout in the payment space in South Africa. Avo, another Nedbank project. Payflex, which is a buy now, pay later, is a customer of ours. We do all of their tech for them. MTN, Easy Recharge, Vodacom Express Recharge, Vodacom VodaPay are all built on top of our technology. And Chipper Cash, which is a new entrant. I think it's now a new unicorn in Africa, $1 billion company, which are in the cross-border remittance space, are building on top of our core product. And we actually acquired MasterPass from MasterCard earlier this year. So all of the, any MasterPass QR code you pay is processed by Ukesh. So that's a bit about us. The kind of cornerstone of our business right now is providing a sort of a fintech as a platform API. So API as a service hosted in the cloud and completely multi-tenanted. It's actually hosted in AWS. And the idea behind this API is to provide pretty much anything that a fintech or a challenger bank would need in order to launch a financial proposition. So going from onboarding and KYC, payments, VAS vending, cash deposits, withdrawals, credit card switching, card issuing, so credit card issuing and acquiring, managing of merchants, customer profiles, QR codes, digital walleting, all of that is kind of encompassed as a multi-tenanted API that can be used by banks and fintechs and telcos. And then they go and build channels on top of that, or we help them build channels. So it could be channels over WhatsApp, like Telkom Pay or Nedbank Money Message examples, mobile apps, web, USSD, still big in South Africa. So basically, people can build channels on top of this Eclipse API in order to launch propositions. This core product of ours runs entirely on Quarkus. We started the migration to Quarkus, as I said, in sort of beginning of last year. And we've got right now about 500,000 lines of code, of our own code, running in production. That doesn't include other people's libraries and open source projects, etc., in play. In the Quarkus universe, we're using REST Easy Reactive, which is the new. It's still labeled as experimental, but we're early adopters, so we're using REST Easy Reactive in production, which is a reactive or imperative REST Easy compliant JAX RS implementation. So you can basically host and serve REST services on Quarkus using the Vertex event loop technologies in a reactive way so that you can do completely non-blocking REST services. We use Jackson for JSON, open tracing. I'll show you a demo of that. Agrel for database connection pooling, Hibernate for JPA, Jaeger for open tracing, MySQL and Postgres. We use both of them on different projects. Nariana, which is the JTA implementation. Context propagation, you know, there's a lot of, when you're dealing with reactive programming, there's a lot of context switching between threads and things, and context propagation allows you to pass context as a request flows, even if it goes through through different threads and thread pools. Microprofile health, microprofile metrics, microprofile open API, Swagger for the presentation of the APIs that I think you saw with Philip earlier, Flyway for database setup and migration. And our code, I would say, is mostly imperative, but there is a mix of reactive coding where we need it. Some of our core components, like our API gateway that we built on top of Quarkus, is completely non-blocking reactive, so that from a throughput and scalability perspective, we've got a completely non-blocking implementation here. So that's where, so it's running in AWS, in ECS to be specific. So we're not using Kubernetes in here. We do have implementations of our technology running in Kubernetes at clients on client sites, but for our own hosting, we chose to run in ECS with Fargate. And in terms of some of the technologies, we've also got wrapped in there. We use MapStruct, we've got Angular for all of our front ends, as well as some React stuff. We, as I said, early adopters, so we're on OpenJDK 16. We use Java Assist, Docker, Maven, Kafka, Hazelcast, to name a few of the technologies we use. But we kind of the mindset that a design is only finished when you can't take anything more away. We don't want to have technology sprawl. We're trying to standardize on as fewer components as possible that do what they need to do, and not just adding things for the sakes of it. Because from an operations perspective and everything, you want things to be as simple as possible. And I'll show you a bit of a demo of that, of running the entire stack on my laptop just now. In terms of our migration to Quarkus, we were on a Java EE application server prior to Quarkus. And when we migrated to Quarkus, we were, to say the least, we were pretty much blown away. So our standard boot time to boot up the stack, if we sort of put it all together into one ear, to, for example, run the whole stack on a laptop or something, was about 41 seconds. And the heap would not go below 120 megs. So sort of your static heap of about 120 megs. We moved to Quarkus and the boot time went to 5 seconds, heap of 20 odd megs, and we could actually run our entire stack with a max heap size of 35 megs. So, I mean, it was slow with that, but we could do it. It was pretty incredible. Our initial load test showed about 30% increase in throughput over standard, on standard REST Easy extension. Then we moved to REST Easy Reactive. That went up to about 50% higher. To be honest, now with the stack as it stands, I wouldn't hesitate to say we're probably about 4 times higher throughput on equivalent hardware on Quarkus than we were on our Java EE tech. And our Docker images are about 100 megs smaller than they used to be. So all in all, there was only a positive story for us when we migrated. Few other things around the Quarkus community. I've just got an example here. We logged some issues on the early release versions of REST Easy Reactive. And I think the 12th of December was a Friday. So Friday afternoon, and within an hour and 10 odd minutes, people were already pushing PRs into master for some of the fixes of things I picked up. The community is passionate about fixing stuff, helping people, you know, between the Zulip chats and the mail groups and Stack Overflow. There's a very vibrant community with a lot of developers. Obviously, the Red Hat guys are core behind that. But, you know, the community has been unbelievable. In terms of running in production, so it's been over a year now that we've been running in prod, and we had 31 seconds of downtime at one point because of a silly configuration change we did during one of our deploys. Other than that, it's been up the entire time. So that's 6 nines uptime on effectively was a brand new platform. It just works. We haven't had crashes, we haven't had issues. and any issues we have had, we pick up in dev and tests, and they get fixed, and it's only a good story to tell there. In terms of our costs, our compute cost is almost the same as what we pay in tax. Our cost on AWS, I'm not showing actual figures, I'm just showing kind of a proportionate breakdown. You can see that our compute costs in AWS is about half of what it costs just to run RDS. And RDS, this is only 2 instances of MySQL. So we've got a MySQL cluster running, which costs us this, and that's our compute. The rest is WAFs and the application load balancers and that sort of thing. So from a compute perspective, Quarkus is very, very finance friendly. After about 6 months of migrating to Quarkus, I actually did a, survey on SurveyMonkey to our dev team. So we've got a dev team of about 25 odd people in India who, it's not freelancers or anything, they're part of our company. And I did a survey to see, once we'd migrated to Quarkus, what were the experiences, what were people thinking? Because, and it was during COVID, we couldn't see the guys face to face and speak to them and have the water cooler chat. So, we just wanted to gather how they were feeling about it, having moved from the other frameworks they had used. And I mean, this was pretty much the feedback. So the question of how would they rate development tooling? Sorry, was there a question there?
No, there was just a interesting grin. That's awesome feedback.
Yeah. So yeah, I mean, the feedback was, and these are guys coming from Java EE and Spring environments, and the feedback was amazing. The dev team just loves it, and that for me, as a founder of a business and people trying to hire and keep developers, you want devs to love what they're doing. And that's where Quarkus has really brought a lot of joy to the dev team. Just at the
On
bottom
that
here,
note,
yeah.
sorry, Paul, on that note, there's a question, are you hiring?
We're always hiring. Yes, we are hiring. We've got a number of positions open to work on exactly this stuff. So if you want, please get hold of me. You'll find me on LinkedIn. In terms of performance, I mean, it's unbelievable. I'll show you some live demos just now. But this is running on hotspot. So this is a JVM, boots up in 600 odd milliseconds. Run a quick load test, get over 100,000 requests per second on a REST endpoint. It's impressive stuff. The framework is built on top of, well, it's basically Vertex, which sits on top of Netty, and then Quarkus has built itself on top of Vertex. So the underlying event loop and event-driven architecture behind Quarkus is the bleeding edge of performance in terms of what you can do on any platform. Okay, so let's jump into some demos. So the first thing I'm going to try and do, and I'm going to shoot through these because I think time is of the essence. So the first thing I will do is let me boot up our entire Java stack, if I can find it here. What this will do is boot up the entire Eclipse stack with all of the microservices packaged together as a monolith, just as a way of booting everything together with database access, everything. And it's now, so the JVM's just kicked off and our 10 microservices all packaged together are all up and booting. They're all up and ready to receive traffic. So that is that previous slide I showed you of all of the microservices and everything that took 40 odd seconds to boot up in our previous technology. All started after 2193 milliseconds. So that's it up. Now what I'm going to quickly show you is is actually, this isn't necessarily a feature of Quarkus. It's something we built on top of Quarkus WebSockets, where we've got a little VM or little ECS instance running in Ireland, which is this server. As it booted up, it actually set up a WebSocket connection to that instance. And it's like ngrok, if anyone's familiar with ngrok. It enables traffic from the internet to tunnel into my VM. So in fact, if any of you wanted, you could go to, let me just exit this here. This is actually our front end, and I'm going to quickly bring up a backdoor that allows me to choose what backend URL I want to use. And this here is actually my laptop. So I'm going to select that as my laptop and log in. And I am now serving a Angular front end, which is calling my laptop. So here are all the requests and responses. And as I'm browsing around and doing things, I can go and change some data here. Oh, actually, I can't. As I'm basically just look around. So as I'm browsing in our admin portal here, all of those requests are actually hitting my laptop. So, you know, one of the advantages of Quarkus, I'm not going to have time to show you the demo, but also I've got a dev mode demo where I could actually go into NetBeans and start changing code while an Angular developer is busy calling my REST endpoints on my laptop. So that whole cycle of having a back-end developer develop something, test it, deploy it, and then having front-end developers consume your API, that falls away. Front-end devs can be consuming APIs as they're being built on people's laptops with basically a few milliseconds turnaround time between changes and what the front-end devs can see. I will quickly, in fact, just to show you that. So let me start this here. If you all want, you can go to this. You can scan this QR code quickly with your phone and go to that URL. And that URL is being served from my laptop right now with this is almost booting. Sorry, I've got some snapshots in here, so it's going to take a little time. Just give me a sec. Okay, if you scan this now, or just refresh if you had scanned it earlier, you should be seeing a little, I think it probably says hello world or something like that. Hello Java world, I think, in your browser. So you are now connecting to my laptop in dev mode, and I can go hello Josie Jug and save that, and you will see that Quarkus will do a rebuild and deploy. And if you now refresh your browser, it should say hello Josie Jug. So this is kind of showing how you could be on the other side of the world deving a front end against a back end I'm busy deving with you. And you could go and say, oh no, please guys, we want this as a JSON endpoint. And I say, okay, cool, I'll change it to JSON. And this is going to complain miserably, but I'm sure if I refresh, I will see something changes. I should probably return a map there or something, but I think you probably get the point on that demo. So some pretty cool stuff. Next thing I want to demo is just a quick framework comparison. So a lot of the slides we're discussing about, the impacts of Quarkus on boot time, performance, memory footprint, being able to build containers, start them up quickly, etc. So what I'm doing, probably something that a Red Hat guy couldn't do, but I'm going to just quickly show you a completely unbiased comparison of various different frameworks. Each of these is kind of a hello world with using the latest version of each of Micronaut. In fact, Micronaut we've got on milestone 2. I've got, let's just see what else I've got here. I've got Spring Boot. I've got Quarkus running in JVM mode with a 30 meg heap. Spring Boot, by the way, was with a 50 meg heap. I've got Helidon running here with a 50 meg heap. And just for a bit of fun, I've also got somewhere over here is, I've got a Node server, Node.js running as well. So let me quickly kick off this, this comparison quick. So here is I'm just going to run a bash script. What it's going to do is it runs a workload test against each of the 6 running containers with a, I think it's a concurrency of 100. So 100 concurrent requests for 3 seconds, and then moves on to the next one, and as it does each one, it picks up what the memory resident set size is, the request per second, and then it does a basic calculation to say how many requests per second can this process process per megabyte of RAM that it's using, just as a metric. You could choose many metrics. I just happen to choose this because it's kind of aligned to the whole ethos of Quarkus being lightweight. So let's just run this. I'm probably not going to get figures as great as it could because I'm running Zoom and everything else. But what you'll see here is Quarkus on hotspot is extremely quick. 132,000 requests per second of a Hello World endpoint. Spring Boot on hotspot is about 1/5 of that. Node.js significantly less still. Micronaut is second in line. Quarkus native, so that is a native Quarkus executable. You will see that it is quite a bit slower than hotspot. The JIT's compiler of hotspot is pretty incredible in terms of the efficiencies it brings. So from a pure throughput performance perspective, you can't beat hotspot. And then Helidon is way behind. And all of these, I've given them enough heap to try and give them enough that they get a great performance result, but not so much that their RSS is too high. So if you look here, in first place, generally for request per second per megabyte is Quarkus on hotspot. Second place, generally Quarkus native. Then onto Micronaut, Node.js, then Spring Boots, and Helidon a long way behind. So this is just, I mean, it's not a real world example. It is just Hello World, but it does give you an indication of the capabilities of each of the platform in terms of the overhead of the underlying technology that's running things. So I thought that would be pretty interesting to see. Okay, let me just kill that. And then what else did I want to show you? Okay, then the final thing I'm going to show you is I've got a quick demo of showing an example of reactive programming versus, or blocking versus non-blocking code. I've got a Quarkus instance running here that's got a blocking endpoint and a non-blocking endpoint. So I can quickly show you the code over here. So over here, we've got a blocking endpoint, which what it does is it does a REST call out to Postman Echo, which is basically a REST service on the internet where you give it a delay, it will sleep for that delay and respond. So I'm calling out, I'm doing something a typical code would do is call out to another service that takes a bit of time to respond, and then it responds back. I'm doing that in a blocking call, and then completely non-blocking where you are doing it with reactive programming, returning a completion stage or a future, whatever you want to call them. So I've got that running here in Quarkus. I'm just going to find the So here I've got a window which is going to run a quick load test against this instance. And I will do that with, firstly, I will do it with blocking. Sorry, that's not what I wanted to do. Here's the load test. Okay. So I'm going to kick off this load test with against the non-blocking endpoint with a concurrency of 200. And so 200 clients are calling as fast as they can into this endpoint, waiting for response, calling again. And it's calling into an endpoint which basically does a call to the internet that blocks for 10 seconds. But I'm doing this in a non-blocking way. So if I go here and as another customer and call the endpoint, you can see it's happily still responding to me. So I'm calling this endpoint, which is undergoing a load test of something that is, calling another endpoint that sleeps for 10 seconds. It's kind of a nightmare scenario, and yet this is happily responding absolutely fine. I now go and run that same load test against the same server, but now a blocking endpoint. And I call the blocking endpoint, so simulate some other customer calling in, and it will time out basically forever. If this was a production environment, effectively our server is down. It's not responding to customers at all. Because the entire thread pool is now blocking, waiting, and the Java process is doing nothing. It's not like it's working. It's not even appearing anywhere. Probably this one down here somewhere, doing like 1% CPU, because really it's doing nothing. All it's doing is waiting on the postman calls to respond, and the server is locked up. There I got the response eventually. And if I did another request, you'd see it would take just as long. So that's just showing the Quarkus ability that, if you want to write good old imperative code, you can, but you can mix it in and go and add in reactive code, completely non-blocking, and it works. So that was the kind of third demo of some of the stuff that we're using in Quarkus. Okay, and I think that's it from our presentations.
Very cool. I loved your presentation. I know we're over time, but if people, I'm happy to stay on if there's questions. I don't know about the other.
I have a
If
few.
you guys are happy.
First of all, the code for these little comparative hello worlds, is that available somewhere?
I can make them available. I didn't have time to make them available, but I will certainly do that. I will put them.
Or if you can zip it all up and send it to me, I can put it on the Josie Jug GitHub and share it with everybody, because it's I love to play around with performance tests and things like that. And because what I want to do is I want to add Spring Native to the mix and see what it does, because it's coming along. Another question, I noticed that you also have nearly half of your money goes to RDS. Are you running plain MySQL or using Aurora? Have you taken Aurora for a spin yet?
No, we chose plain MySQL. We've got a lot of experience in it, and we didn't want to play with too many changes at once.
Okay.
So we stuck with plain MySQL. In fact, we mix and match between Mariah and plain MySQL.
Yeah. No, I was just wondering, because we're at a point now where we've got an app that's still, the traffic is so low, it's difficult to determine the benefits, whether using Aurora or, in our case, Postgres. And Aurora costs a bit more. initially, and I was wondering if you had any inputs on that. But it's interesting. Just a comment for anybody out there. You would have seen all those other bars, and a lot of them are things like gathering information so that when something goes wrong, you know what happened. And in the cloud, that's very important. And if you want to run a business that depends on your customers using it and making payments, then those kinds of things are important. And the guys must never forget that. People tend to try and skimp on that. But that's money that's never wasted. And the same for RDS. That big bar, half of it is because you're probably running mirrors or a replica, which means that you don't have downtime. So you pay a premium, but you have availability. Whereas in the good old days,
you can't afford downtime in the payment space.
You can't afford it.
And just in terms of your comment earlier, in fact, something I forgot to show you was just the Jaeger open tracing, which we have completely integrated into everything. So
invaluable.
Request and response between all microservices we have. Request down to what are the threads in use, down to the SQL queries and how long they took of traces. And then all of this is actually within a PCI DSS environment. So we hash out anything that is sensitive data. But we basically do not allow people to use logs. Our intention is that if a person gets an error, there's a trace ID and you look in Jaeger, and that's that. That's the way we do operations. Trawling log files is very much 5 years ago.
Exactly. Okay. So let's just recap with the community. Everybody had access to the feedback form, so you can join the JetBrains giveaway if you want to. You can ask Philip to put you on the list for a t-shirt.
Paul, if you can just mute your microphone, there's a bit of a...
Yes, thank you. You can join the Slack if you want to ask questions there. The Slack is open at the moment, but I'm actually going to make it private tomorrow morning so that it's limited to the people who attended this meetup. Don't share that feedback form with everybody else because it just reduces your chances of winning the JetBrains coupon. And I've got the list of people who are actually on here. So we want to reward the people who joined, give them an opportunity to get the coupon, order the t-shirt, and I see some familiar faces, some new faces, and I cannot wait for the opportunity when we get to meet face-to-face around some pizza. But I imagine that's probably going to be at least a year away, if not more, depending on your age. So thank you, Philip and Paul. It's been enlightening. And I'm pretty sure you're going to see features of Quarkus show up in other areas. Because the projects always borrow from each other. As I say, I mean, Spring Native there's lots of similarities. It has IoT, it has compiled to native. They've been doing a lot of work to try and improve the I think a lot of it is stuck in their the proxies that are all code that gets taken care of by AOT. So that's why I want to do a comparison there. For everybody out there, keep learning, keep sharing, keep safe. Thank you for joining us. And tell your friends about the nice things you saw, and invite them to join us next time. And maybe we'll get somebody who can send pizzas to everybody who joins. Maybe one day. So thank you, everybody. Any last words from you, Philip or Paul?
From my side, just thanks for the opportunity to share this with you, and you're also welcome to find me on the internet if you have any questions. I'm usually on Zulip. You'll see when you go to Quarkus.io, there's a Zulip channel. If you have any questions, if you ask there in general, somebody will answer you, but you can also ping me directly there.
Okay.
Yeah, and from my side, thanks. I mean, thanks, Philip, for inviting me. It's been great.
Thanks a lot, Paul. Thanks for joining us, Rory, and everybody out there. Keep safe. Look after yourself. This COVID is no joke. I can attest firsthand. I'm lucky to have survived it without needing to go to the hospital. So take care of yourself, and until next time. Bye-bye.